So our next one, you're going to, I've told you go and read the theory part, then calculation of standard error in sampling. So when calculating a standard error in sampling, we say standard error is equals to standard deviation over n. So this one, it's standard error. SE is standard error. SD is standard deviation. Not sure with the spelling, but it's like that. So an example, a firm purchases a large quantity of metal cut off and wishes to average, this is not average the weight of an off cut. A random sampling, now this is n, of 625 is weighted and found that the mean sampling weighted is 150 grams with a standard deviation of 30 grams. What is the standard error of the mean? So when you want to find the standard error of the mean, you say standard error is equals to standard deviation over n. So where is our standard deviation? It's here down. It's saying with the mean sampling when is this, with a standard deviation of 30 grams. So when you see something, a random sample, know that is our n. Okay, so this is the formula. Standard error is equals to SDD over square root of n. So your answer needs to be 12. Then when you're told what will be the standard error if the sampling size was 1125, so you already been given the n, which is 1125. So you say standard error is equals to SD over n. Then you get your answer something like this, 0.89 grams. The next, a sample of 80 is drawn from a population of 800. The sample standard deviation was found to be this. So a sample of 80 is drawn from the population of 800. So standard error is equals to standard deviation. I guess I've written the formula somewhere. Here it is. Standard error is equals to standard deviation over n, and our sample is 80 and our standard deviation with the standard is 6. So you write 6 over 80, you get your answer. Then same to this, a sample of this with the mean of this, a sample of this, you'll just check, find the standard error, same. So the next topic we are going to do is estimation of population of proportion. So what is going to slightly change over here, we are not going to write the SD, we are going to write P times Q over N. The P means the mean of proportion of success, and the Q, you take 1 minus P, and then N is the sample, so it's still there. So when you're given such a question, a random sample of 400 trails passenger is taken at 55%, are in favor of a new proposed timetable with 95% confidence level. What proportion of all rail passengers are in favor of the timetable? So when you're given a confidence level of 95% or 99%, this 95%, it will change to 0.05, which is in confidence level that your rating is 1.96. This it can it can be also 5%. It can be this direct, it can be 5%, that means imetoka 100 minus 95, or this 5 over 100 ikawa 0.05. You might be given either in this format. So in 99 we have 1%, we have 0.01, and then this one will be 2.58, and then let me write it here. So if you're given a confidence level of 95, or this 95, you take 100 minus 95, you get the 5%. Or this 5%, it has changed into decimals over 100. In short, it will be 0.05, which is equals to, you're not supposed to write directly like this, so it will be 1.96. If you're being given 99%, or 1%, or 0.01, it will be 2.58, just like that. So like this one, you're given 95%. So you want to know our P. Our P, a random sample of 400 rails is taken by at P. 55% are in favor. So this P, this 55%, you write it over 100, it will be 0.55. Then you take Q, Y minus 0.55, you get 0.45. Then you say standard error is equals to P times Q. So you take this P, 0.55 times 0.45 over N, which you're given a random sample of 400 rails. You get our answer 0.025. But after that, remember, we got P. We say that we are 95% confident that the population is between P plus or minus 1.96. This 1.96 imetoka wapi? We are given a confidence level of 95%, which is say it's 1.96 times the standard error. The standard error yenye umepata hapa chini when calculating this 0.025. So 0.55 plus or minus this